Good morning, dear students. Today is 24th December 2020, and my name is Ferhan Mazher. And right now, I am with the 11 Cambridge class. We call it the O3 class, and we are practicing the past papers. Today, we are working on the May June 2017 paper, and the name of the paper is 2-1. This is a theory paper from the Zone 1 or Variant 1, and we are in this session we are going to attempt is section B. So we have question number 9 in front of your screen, and the first question is: different energy sources are used to generate electricity. Energy sources are renewable or non-renewable. Nuclear energy is described as a non-renewable source. Explain what is meant by a non-renewable energy source. A non-renewable energy source is a source uh, which cannot be replenished, which once used will run out, which once exhausted, you cannot reproduce it. So that source is called non-renewable. For example, oil is non-renewable. Once you used it, you cannot reproduce it. Once it's exhausted, you cannot recreate it. So let me see the marking scheme, what the marking scheme says. Question number 9. Okay. It says that not being replaced or will run out. So Muskan, write its answer.
Non-renewable energy source is which will run out.
Which will run out, yes. Once exhausted, you cannot recreate it. Okay, so that was 1 mark question. Now we move to the next part. 4 of the energy sources used are hydroelectric, oil, geothermal, wind. Write the name of these energy sources in the correct column of the table below. Non-renewable. Non-renewable, oil is non-renewable. Renewable and caused by the energy from the sun. The hydroelectric is caused by the energy from the sun because the sun evaporates the water from the oceans and they make clouds, and then it rains on the mountains, and then we collect the water in the dams, and from there we make the electricity. So hydroelectric is caused by the sun. Wind is also caused by the sun because of the difference of temperature in different areas, the winds blow. So the wind and the hydroelectric, they are renewable and they are caused by the sun. So in the second column, you will write wind and hydroelectric. Renewable and not caused by the energy from the sun, and that will be caused in this category. We will write geothermal. Geothermal is the energy which is coming from the core of the earth, and that is not due to the sun. Okay, so in the third column you will write geothermal. Okay, this was a 3
Yes,
mark
sir.
question.
Yes, sir.
It is a 3 mark question. You are done with this thing?
Yes, sir.
Okay. So the third part, state one way in which using nuclear energy is better for the environment than using the oil. You see, when we use the nuclear power plants do not emit carbon dioxide. They do not emit sulfur. They do not emit carbon monoxide. They do not emit those gases which will cause global warming. Muskan, if you have written your answer, you can read it so we can check it.
Nuclear power plant produce less greenhouse gases. Nuclear power plant do not emit gases which led to global warming.
Okay. So, for example, carbon dioxide, carbon monoxide, sulfur dioxide. Okay. The fourth part is state one way in which using nuclear energy is worse for the environment than using. If a leakage happens in a nuclear power plant. If an accident happens in a nuclear power plant, you see what will happen. The so what will happen? The radiation which will come out, that will spread in a certain area, for example 1 kilometer up to 3 kilometer, or maybe up to 20 kilometer. So in the radius of the 1 kilometer you have to evacuate everything. The human beings cannot live there. Another big, so this is the problem with the nuclear power plant. Nuclear power plant safety history is very good, but if a leak happens, if an accident happens, then the harm caused will be, you can see, it will be immense. For centuries, that area will remain radioactive. So no human beings can survive there. And another very important thing is that the wastage of the nuclear power plant, once, for example, uranium is used as, or plutonium, uh, is used as fuel. For example, uranium is used as fuel. So once it's used, the fuel cells which are used, the wastage fuel, to dispose of that fuel is very difficult. You see, to safely dispose of that uranium fuel is very difficult. You have to dig tunnels and tunnels, and you have to bury that fuel there. So it's very costly. And if you throw, for example, some countries, what they will do, they will take their their nuclear reactor uh, waste, and they will just dump somewhere in some poor countries or in the waters of that country. So from there, the radiation will come out, and it can danger the human life. It can be a big danger for the human life. It can be a big danger for the marine life. It can be a big danger for everything there, because when you dispose the nuclear waste in an area, so everything will become radioactive. So that is the big issue, disposal of the waste in a nuclear reactor. So, Muskan, what you have written?
Disposal of nuclear waste is difficult. और मैंने
Yeah, nuclear.
the area will become radioactive for centuries.
Yes, it will remain radioactive. If an accident happens, then it will be a big problem. Okay, so I'm just for a second cut off from the internet. Let me do. That is the big issue we have all the time. So unfortunately, my internet is down. It is okay. So now my screen is not showing to you, uh, but the recording is on. So let me, or we can just discuss the questions. Okay.
Yes, sir.
So the next question is on your, but this is not now showing on your screen. Okay, that was 1 mark question. Okay, so question number 9 and its B part, figure 9.1 is a block diagram of of uh, produces electrical energy from oil. Fuel energy in, so here we have, if you have your hard copy in front of you, so he says that we have fuel energy input from the oil that goes into a burner that gives out thermal energy, which is heat. Then that thing goes to the boiler that, and it gives internal energy of steam, and then it goes to a turbine. Then it goes to where? Here we have the box, and nothing is written in it, and that box gives out electrical energy output. So it's a, uh, you know, uh, block diagram of a power station. So that is figure 9.1. I hope that you have the hard copy in front of you. So write the name of the missing
Yes,
part of
sir.
the power station in the empty box on the figure 9.1. So on the figure 9.1, you see in this
It's
empty
generator.
box, here we should have a generator, because the generator will be taking energy from the turbine, the mechanical energy from the turbine, and it will be giving out electric energy. It's a one mark question. So in that box you have to write generator.
Yes, sir.
So then he says, and the second part is state the form of energy that the turbine possesses. The turbine possesses the mechanical energy because its blades are turning. So it has mechanical energy. Let me see the marking scheme also.
Can we write
So to make
kinetic energy?
the kinetic energy is mechanical energy. It is mechanical energy. Have you written that?
Yes, sir.
Okay. Okay. So let's go to the next part. And in the next part, he says, let me read the question. Okay. It's a one mark question. Sorry, it's a numerical. So listen very carefully. A small boiler in the power station contains 24 meter cube of water at 30 degrees centigrade. High pressure in the boiler increases the boiling point of water to 120 degrees centigrade. Thermal energy supplied to the boiler is used to heat the water from 30 degrees centigrade to 120 degrees centigrade, and then to turn it all to steam at 120 degrees centigrade. The density of the water is 1000 kg per meter cube. The specific heat capacity of water is 4200 joules per kg per degree centigrade. The specific latent heat of vaporization of water is 2.3 x per 6 joules per kg. Calculate the mass of water in the boiler. You see, his question is mass of the water. The volume of the water is given 24 meter cube, and the density of the water is 1000 kg per meter cube. So you can find out the mass. The density is equals to mass divided by volume. So mass is equals to density multiply volume. Mass is equals to density multiply volume. So you can multiply the 24, which is the volume, with 1000, which is the density. So you will get the answer. 24,000 kg will be the answer. Muskan, you have done this. This is a one number numerical.
Yes,
This
sir. I have
part is
done.
one number. Okay. So my internet is back. So let me redo so I can share the. So I'm back. The light is not right now. We don't have light. I'm working on UPS, and so we have to stop because yeah. So my dear students, we did. So I was almost here when I lost the internet, and you can see that this was the two questions which we did, and then we moved to this flow chart. This is the block diagram of a power station, and this block was missing where we have to write generator. And then this was the question: state the form of energy that turbine possesses. That's the kinetic energy. And then we are working on this numerical. In this numerical, the first question they ask is find out the mass of the water, and the thing is very simple. Mass is equals to density multiply volume. The density is given, which is 1000, and the volume is given, which is 24 meter cube. Simply multiply them, you get the answer 24,000 kg. 24,000 kg. So Muskan is done with this part. I hope you are also able to do it. Calculate the total thermal energy supplied to the boiler. You see, in this part, we have to calculate the total thermal energy which you provided. So it has, there are two kinds of heats. Or you can say I can divide the total heat into two portions. One, when the heat was used to raise the temperature, and the other is when the heat was used to convert the water into steam. So in the first portion, the heat is equals to mc delta theta. Heat is equals to mc delta theta, where m is the mass of the water, c is the specific heat capacity of the water, and delta theta is the change in temperature. The temperature of the water changes from 30 to 120. So I think it's a 90 degrees centigrade rise in the temperature. When the temperature of the water rises from 30 to 120, so the change in the temperature is 120 minus 30, that's 90 degrees centigrade. So now, Muskan, can you calculate H1, the heat number 1?
It's 9072 and then 6 zeros.
Okay. So then we will calculate the heat number 2, and that will be the heat which is required to convert the water into the steam. The formula for that is heat equals to M multiply L, where M is the mass of the water and L is the specific latent heat. You see, the specific heat capacity of the water is given, the specific latent heat of the vaporization of water is also given. So heat is equals to ml, that's heat number 2. So calculate that, just put the value, the mass is 24,000 and the latent heat, the specific latent heat of vaporization of the water is 2.3 x per 6 joules per kg. So simply multiply them. You will get the heat 2.
The answer is...
Muskan, are you done with this thing?
Yes, sir. 5.52 x per 10.
Okay. So the total heat, the actual question is what is the total heat? The total heat will be heat 1 plus heat 2. So simply add them. The heat which was used to raise the temperature and the heat which was used to convert the water into the steam. So what is your answer?
6.4 x per 10.
Joules. So it's good. So I hope that everybody has understood this question. This part especially involves two steps. Heat number 1, mc delta theta, and heat number 2, which was m multiply L. One heat was to raise the temperature and the other heat was to convert the state. And total energy will be the sum of both the heats. Okay. So let's go to the next part. Sorry. The electric energy output from the station is transmitted over long distances at a high voltage. Explain why electricity is transmitted at high voltage. You know, whenever the electricity is sent through the transmission lines, due to the resistance of the transmission lines, electric energy is converted into heat energy, or electric power is converted into thermal power. So which is a waste of energy. So what we do at the power station, we install step-up transformers, and those step-up transformers increases the voltage. When they raise the voltage, the amount of current decreases. So you see, when the amount of current decreases, this helps to reduce the power loss in the transmission lines, because the power loss in the transmission lines is given by the formula P is equals to I square R. So when we reduce I, what happens? The power loss decreases. Okay? Do you understand?
Yes, sir.
Okay, that's good. Okay, so let's move to the next part. I think again the internet is fluctuating. So what is happening is that the screen from where the update is shared, there's something wrong with it. Okay, so it will be again sharing. The internet is down. Okay, so that was the question. It was a two-mark question. Let me show you the marking scheme as well. So on your screen, you can see number 9B, its fourth part. So I hope it's done. Muskan, what you have written? What is your answer?
Low current on output side.
Uh,
Heat is lost in cables.
that's it.
Power loss in transmission lines. So thinner wires should be used.
You see, you are just writing the main points which he wrote in the marking scheme. We listen carefully. We increase the voltage so that the current can be reduced. When the current is less, there will be less heat loss in the transmission lines. When there will be less current, you can also use thinner wires, which will be less expensive as compared to thicker wires. G, what you say?
Yes, sir.
It's a two-mark question, okay?
Yes, sir.
So you should connect that why we are transmitting the electricity at a very high voltage. Because when you increase the voltage, the current decreases. When the current decreases, the power loss in the transmission lines decreases. When the current decreases, you can use thinner wires. Okay? You
Yes,
understand?
sir.
Okay. So let's move to the next question. And let me take out the next question. It's question number 10. On the figure 10.1 shows two rays from an object that is placed in front of a plane mirror. On figure 10.1, draw two reflected rays and locate the position of the image. Let me copy it from here and take it to the paint. Okay, so let's copy and we will put it in the paint so I can work on it. Let me increase the size. Okay, so here we go. The file is here. Now you see what I will do with the help of the scale. First of all, I will draw two normals. The normal should be here. Normal is a line which makes 90-degree angle with the point Okay, you can see, you understand, I have drawn normals at the point of incidence for both the rays.
Yes, sir.
Okay, okay, then with the help of the protector, I will measure how much is the angle of incidence for this ray. And I will, this red line is basically showing, I will keep the angle of incidence and angle of reflection equal. So let me say that this red line is basically showing the reflected ray. This angle of incidence and angle of reflection should be equal. In the same way, I will draw this. Here the angle of incidence and angle of reflection should be equal. I will prolong these reflected rays behind the mirror. And when I prolong them behind the mirror, the line should be dotted because it's an imaginary line there. Okay? In the same way, I will prolong this second reflected ray behind the mirror. So where these two rays intersect each other, you see they are intersecting each other where? Here. Here the image will be shown. Muskan, do you understand this phenomenon, this procedure?
Yes, sir.
Okay. So this is how we will do this. Let me go back to the question. So the question was on the figure 10.1, draw the two reflected rays and locate the position of the image. It was a 2-mark question. Apart from its position, state one characteristic of the image. You see, this is a plane mirror. And in the plane mirror, the image formed is virtual. The image formed is upright. The image form is laterally inverted. The image formed has front to back inversion. The image formed has the same size as that of the object. The distance of the image from the mirror and the distance of the object from the mirror, they both are equal. So here you only have to write one characteristics. You can write any characteristics. I named all of them.
Yes, sir.
Are you done with this thing?
Yes, sir.
Okay. So let's move to the next part. Figure 10.2 shows two wave fronts in a ripple tank. Sorry, shows wave fronts in a ripple tank. They move in the direction of the arrow. The wave hits the boundary between two regions and the wave slows down as it enters the shaded region. So when the wave will enter the shaded region, the wave will slow down. When the wave will slow down, the wavelength will also decrease. So the wave fronts will come close to each other. Plus, the wave front's direction, it will be tilted towards the normal. So his question is, state what is meant by the wave front. So the definition of the wave front is a 2-mark question. Wave front is an imaginary line which join all the points adjacent to each other and which are in phase. Wavefront is an imaginary line which join all the points which are in phase and are adjacent to each other. Wavefront is an imaginary line which join all the points in a wave which are adjacent to each other and are in phase. That imaginary line is called wavefront. Muskan, do you have you written this definition?
Yes, yes,
Okay.
sir.
So what definition you have written?
Wavefront is particles on wave with same phase.
Wavefront is an imaginary line which join all the points in a wave which are adjacent to each other and are in phase. It's a 2-mark definition. What do you say?
Yes, sir.
Have you rewritten it?
Yes, sir.
So kindly read your answer.
Wavefront is an imaginary line which
Huh?
joins all points in a wave which are adjacent
And
and have same phase.
yes, that's the exact definition. This will get you 2 marks. Otherwise, you will get only 1 mark. So he says both reflection and refraction occur at the boundary. On the figure 10.2, draw the reflected wavefronts, and on the figure 10.2, draw the refracted wavefronts. So it's totally a 3-mark question, which requires construction. For that purpose, you will need scale, you will need pencil, you will need your protector also. Do you have these things with you?
Yes, sir.
Okay. So try to understand. It's a 3-mark question, and try to understand how this is done. Let me copy it from here. Okay. So we have to done both the okay. So you have to do both the reflection. First of all, I will draw normal. With the help of the pencil, you need to draw normal here. Normal is a line which makes 90-degree angle with the surface of this boundary. So you can see I have drawn a normal there. You will draw the normal. You will put the crosshair. You will put the crosshair of your protector at the point where the direction line of the wavefront touches the that shaded region. At that point, your crosshair should be, and then you will mark the 90-degree. The 0 marks of your protector, both the 0 marks should be on the boundary, and the crosshair of the protector should be on the point of incidence. And just put the 90-degree dot on the paper and then join it with the boundary, so you will get a normal. So if you know how to draw normal at the point of incidence, I have already drawn there with the green color. Draw the normal. Okay.
Yes, sir.
Okay. Then what we will do, we will draw the reflected ray. The reflected ray will be with the help of the protector by making sure that the angle of incidence and angle of reflection, they both are equal. See, You have to make sure that this angle of incidence and this angle of reflection, they both are equal. You have to make sure this angle of incidence and this angle of reflection, they both are equal. You understand?
Yes, sir.
Okay. So then I will draw the wavefronts, and the wavefronts will be in such a way, for example, when this wavefront, I will draw this wavefront. This should be in such a way. This blue color thing is the wavefront. It should be making 90-degree angle with this that red line. Understand? For
Yes, sir.
example, this wavefront, I need to make this wavefront in such a way that it should be making 90-degree angle with that red line. You can prolong that red line. I can prolong that red line behind here. So to make the things more easy, I have prolonged that reflected ray. So for example, this wavefront, I have to draw it in such a way that this blue line should be making 90-degree here. I am not bringing it here, but it should be making 90-degree with this red reflected line. So this is how you make the reflected wavefronts. I can draw another one. So from here, they should be in such a way that they make 90-degree angle with this red line, So when you put your scale there, I'm not prolonging them into this area, but this blue line should be making 90-degree angle with this thing. You understand?
Yes, sir.
Okay. This is the reflection. For refraction, first of all, I need to draw a line, direction line. You see, here is the direction line. This means when the wavefronts will enter into this area, they will be bended towards the normal. Okay. So this black line I have drawn, that shows the direction of the waves in this area. Because here the waves will slow down. That's why I have shown that they will bend towards normal. Okay. You can see they have not followed their original path. They have changed. Now I have to draw the wavefronts. The wavefronts will be in such a way that they should be making 90-degree angle with this direction line, this black direction line. Okay, let me change the colors. Okay, now I will draw, let's say, this wavefront. I will draw this wavefront in such a way that it should be making 90-degree angle with that direction line. No. I need to move it little. Yeah. Okay. You see this angle here with the black line, that should be 90. Okay. Let me draw another line here. These wavefronts should be parallel to each other. Okay. Let me draw another one. They should be parallel to these previous ones. Okay. Let me draw another one. Okay. So this is how you draw the wavefronts which will enter into that water where the waves have slowed down. They are slow here. So there you can see the wavefronts have moved closer to each other. Muskan, are you drawing on your copy? On your hot copy?
Yes, sir.
Okay. These new purple wave fronts, they make 90-degree angle with the direction line, that black direction line. That's a rule. The wave front should be making 90-degree angle with the direction line. The rest of the wave fronts, I I have drawn on a single rule. That is, all the wave fronts should be parallel to the first one, which I have drawn. Very simple.
Yes, sir.
Muskan, when you are done, kindly let me know.
Done, sir.
Are you done with this diagram?
Yes, sir.
Okay, it's a 3 marks diagram. Okay, okay, we are done with this part. A loudspeaker produces a sound of frequency 2 kilohertz. The wavelength of this sound in air is 16 centimeter. Calculate the speed of the sound. You know, V is equals to F lambda. V equals to F lambda. So if you want to find out the speed, the formula is simple. V equals to F lambda, where F is frequency, lambda is wavelength. This is 2 kilo. 2 kilo means 2000. So multiply 2000 with 16 centimeter and you will get the answer. The answer will be in centimeter per second. Muskan, multiply them, get me the answer. You have your calculator with you? Do you have your calculator?
3,200.
2000 multiply 16 cent 2000 hertz multiply 16,000. 16 centimeter, sorry, I said 1000. 16 centimeter. So what is the answer?
32,000.
So it will be 32,000 centimeter per second. Write the unit also with it.
Done, sir.
Okay. It was a 2 marks numerical. State the range of frequencies that can be heard by a healthy human ear. The audible frequency range of the normal healthy human ear is 20 hertz to 20,000 hertz. Twenty hertz to 20,000 hertz.
Yes, sir.
Muskan, you have written this answer?
Yes, sir.
He says calculate the smallest wavelength of sound that can be heard by a healthy human ear. So the formula is very simple. V is equals to F lambda. And let me show this also on your screen. Bring it here. So we know that the V is equals to F lambda, I don't know, multiply wavelength. Wavelength. Okay. So if you want to find out the smallest wavelength, the formula for the wavelength will be V divided by F. The speed of the sound you just The speed of the sound was how much? 32,000 centimeter per second. And you divide it with the frequency. Because we want the smallest wavelength, so the frequency's largest value should be put here, which is 20,000 hertz. Okay? Why I put 20,000? Because I want the smallest wavelength. So kindly on your calculator divide 32,000 divided by 20,000.
1.6.
1.6 centimeter. That will be the wavelength, the shortest wavelength. 1.6. Let me check the answer. 1.6 centimeter is the answer in the marking scheme. Okay, next question. Describe a simple experiment to show that the sound waves obeys the laws of reflection. You may draw a diagram if you wish. Okay? Describe a simple experiment to show that the sound waves obey the law of reflection. You may draw a diagram if you wish. Okay. So let me show you. It is how much marks? 3 marks. You can also include the diagram. And let me take out this experiment from the. I also have this chapter, I think, in my documents. Sound. Let me see if I have this chapter. Sound. This chapter here. Let me take out. Here that experiment is written. So from there you can write that experiment. Sound. Muskan, can you see this on your screen? Activity 11.3.
Yes, sir.
So we have to write this activity in the answer. He says take 2 identical plastic pipes of suitable length as shown in the figure. This is the figure. This is that figure. Okay.
Yes, sir.
Arrange the pipes on a table near a wall. Place a clock near the open end of one of the pipes and try to hear the sound of the clock through the other pipe. Adjust the position of the pipe so that you can hear the sound of the clock clearly. Now measure the angle of incidence and angle of reflection and see the relationship between the angles. You will see that they both are equal. Okay? This is that diagram. Kindly, Muskan, write these lines in your answer.
Sir,
Yes.
I didn't understand this experiment.
You see what we do? We take 2 pipes. We have a wall and we have 2 pipes. And what? Let me explain to you. You see this white thing, that's a wall. And this is a pipe and this is another pipe. This is a table. On the table I have this pipe, plastic pipe, and this, and this open end of this pipe I have placed a clock. On the other end, this is a barrier between both the pipes. You can put a book between both the pipes. So with this other pipe, you will place your ear and you will move this to the clockwise or anti-clockwise, clockwise and anti-clockwise. Somewhere, when you will be moving this second pipe, at some place, the sound of the clock heard by your ear will be maximum through the pipe. At some point, it's a hit and trial method. When you will be moving the pipe clockwise or anti-clockwise, hit and trial. At some point, you will notice the sound heard through the pipe is loudest. So the point at which you heard the sound loudest, just stop the pipe there, this second pipe. Then mark the positions of the pipe 1 and pipe 2 on the paper, and then remove the pipes. So you will get those dotted lines which are showing on the table. So if you will check the angle of incidence and angle of reflection, you will observe that they both are equal. This shows that the sound waves do reflect, plus they obey the laws of reflection.
Which angles would be equal?
They will be 100% equal.
Which angle, sir?
The angle of incidence and angle of reflection. The angle this pipe is making and this pipe is making with this normal. Can you see on your screen? So this is the angle of incidence, this will be the angle of reflection. This is exactly like the reflection experiment of the light, but here we are using sound. The sound is being produced by that clock, that sound waves goes, and from the wall they get reflected, and through the second pipe we are able to hear them.
Sir.
Do you understand?
Yes, sir.
If you lift the second pipe little bit upward, the sound coming to your ear will reduce. The loudness will reduce. Okay?
Yes, sir.
So this is the experiment. You can stop when you will be watching this video, you can stop this video and you can write this activity 11.3. This is the answer. And you can also make that diagram. Okay?
Sir.
So let's go to the next part. It was a 3 mark. Let me show you the marking scheme as well. What the marking scheme says. He says tube or other method to produce narrow beam of sound on the source and or on a detector. Stated detector or stated reflector. Detector moved to find maximum loudness or angle of incidence and angle of reflection measured with suitable experiment. So you have to write that activity, okay? 11.3, which I showed you on the screen. Muskan, can we move to the next question?
Yes, sir.
Okay. Question number 11 is on your screen. A student connects a thermistor in series with a battery and an ammeter. He uses the resistance of the thermistor to determine temperature. In the space below, draw a circuit diagram showing the thermistor, the battery, and the ammeter. So we have a battery, we have a thermistor, and we have a ammeter. Let me show this in the paint. That's how we'll do. A thermistor, a battery, and an ammeter. Okay. So I can draw this in the paint. So let's take out a new. So let me show you this. Okay, now I have this pencil. Okay, so this is the symbol for the battery. One big line, one small line. So here I have drawn a battery. From the positive terminal, I will take the connection. Then I have to connect an ammeter. The ammeter is always connected in series. So here I will connect an ammeter. This is an ammeter. We write A inside it. And because I'm doing it with the help of the mouse, so it's a bit. Then we have to write there the thermistor. The symbol for the thermistor is you draw a rectangle. You draw a rectangle like this. And then you draw a hockey. We say hockey. See, like this and like this. And then I will bring it back. This is the symbol for the thermistor and this is the symbol for the ammeter. Muskan, do you understand?
Yes, sir.
I have connected a battery, an ammeter, and a thermistor. Okay. So, let's move to the next part. This was a 3 mark. In the space below, draw a circuit diagram showing the thermistor, the battery, and the ammeter. We are done with that. The student places the thermistor in a water bath at various temperatures and records the reading on the ammeter. Figure 11.1 shows how the current varies with temperature. Okay. How the current varies with the temperature. Okay, this is the diagram. So on the y-axis we have current, on the x-axis we have temperature. So you can see as the temperature is increasing, the amount of current is also increasing. The potential difference across the thermistor remains constant. The resistance of the thermistor is 240 ohm at temperature of 20 degrees centigrade. Using the figure 11.1, calculate the potential difference across the thermistor. V is equals to IR. V is equals to IR. The resistance is 240. Let me write here. You can also, V is equals to I and multiply R. We know I at 20 degrees centigrade. From this graph, I can find out the I. Let me increase the size of this graph so you can see it more clearly. At 20 degrees centigrade, what is the value of the I? You can see here. From 20 degrees centigrade, I come to the graph and then I check the value. This is the value. That is 1, 2, 3, 4, 5. So it will be 0.05 ampere. From the graph at 20 degrees centigrade, I know the current flowing through the thermistor. That is 0.05 ampere. Muskan, do you understand? I am using this graph to find out the amount of current.
Yes, sir.
Okay. So I know the current at 20 degrees centigrade. I know the resistance. So the current value, I know the current is 0.05 and I will multiply it with resistance, which is 240. So what is the answer? Muskan, multiply 0.05 on your calculator with 240. So what will be the answer?
12.
So the battery, the voltage is 12 volt. Let me check. 12 volt is the answer. Let me check the marking scheme. Yeah, on your screen you can see 11B first one part. 12 volt is the. Muskan, do you understand this?
Yes, sir.
Okay. So we are moving to the next part. The resistance of the thermistor at the temperature 40 degrees centigrade. The voltage, 12 volt, we know that, and I can find out the. So I know that the V equals to I multiply R, and what they want the resistance. So the R value will be equals to V divided by I. And in the question, he said the value of the V is not changing. We just calculate is 12 volt divided by the amount of current at 40 degree. So I will use that graph. The amount of current at 40. So from this 40 degree centigrade, go to the graph. So what is the value here? It is 0.14. No, it will be 0.12, sorry. It will be 0.12 ampere. It will be 0.12 ampere from the graph. I know how much will be the current at 40 degrees centigrade. 0.12 ampere. So I'll put the value here. So 0.12. Muskan, you have your calculator with you? Kindly get the answer.
100.
100 ohm. So the resistance will be 100 ohm. Let me check the answer. But on your screen, you can see clearly 11B first, second part. The final answer is 100 ohm. Do you understand this? It's easy.
Yes, sir.
Okay. Okay. So let's move to the next part. Okay. On your screen, the resistance of the thermistor is 240 ohm at the temperature 20 degrees centigrade and 48 ohm at the temperature of 60 degrees centigrade. The resistance of thermistor does not change linearly with temperature. Describe how the resistance at 20, 40 and 60 shows this. Okay. What was the resistance at 240? Sorry, what was the resistance at 20 degrees centigrade? That was 240. At the temperature of 40, the resistance we just calculated, how much was that resistance? 100, I think. That was 100, I think you just calculated.
Yes, sir.
Okay. And then at the temperature of 60, the resistance is 48. He gave that in the statement. So you see, there is an equal change in temperature. There is an equal change. There is a uniform change in the temperature. 40 to 60. Was the change in the resistance also same? From 240 to 100, from 100 to 48. Top of 140 ohm. And then from 100 to 48, this is just 52. So in the temperature, there was a uniform change. But the change in the resistance is not uniform. You have to show with the calculation. Because when the temperature changed from 20 to 40, the resistance changed from 240 to 100. So there is a 140 ohm change. When the temperature changed from 40 to 60, the resistance changed from 100 to 48, which is just 52. So for equal change in temperature, the change in the resistance is not equal. So that's why I know this is not a linear change. If the same change has taken with the same equal change in the temperature, then we
Sir,
can say they are linear.
from 40 to 60, the resistance was.
The resistance changed from 100 to 48, which is a change of 52. The resistance changed from 100 to 48. At 40, the resistance was 100. At 60, the resistance was 48. So there is a change of 52 degrees centigrade. So you can write your argument for equal change in temperature. There is for uniform change in temperature, the change in the resistance is not uniform. He says that description of change in resistance in two equal changes in temperature. Okay, 240 to 100 and from 100 to 48. Difference values obtained are not the same, with one value shown in the figure 140 and 42 degree. So kindly write your own argument and we will see what you have written. Yes, kindly, if you have written your argument, then we can read it out. I will love to hear it.
There is a
Yes.
uniform change in temperature.
Yeah.
Change in resistance is not same because when temperature was
Yeah.
changed from 20 to 40 degree, the
Yeah.
resistance changed from 240 to 100.
Yeah.
But when temperature changed from 40 to 60 degree, the resistance was 100 to 48, which is change of 52.
Yes. So the change in the temperature is uniform, but the change in the resistance is not uniform. So that's why it's non-linear. For equal changes in temperature, the change in resistance is not equal. It's not uniform. So they are not linear. It's non-linear. Muskan, do you understand this idea?
Yes, sir.
Okay, okay, okay. So we are going to the next part, which is, I think, the C part. Oh, it's a big question. 3 mark question. C first part. Describe the structure of a thermocouple thermometer. You may draw a diagram if you wish. So we have to describe the structure of a thermocouple. Let me go to the paint and there I will draw the thermocouple. So in thermocouple we have two different, uh, you know, we have a wire which is made of iron. Let me say that this black color, this is basically representing what? Iron. So this is basically iron. It's quite difficult to write with the mouse. Okay. And then we have a copper wire. So here I have a copper wire. So the copper wire will have a voltmeter attached to it. Okay. So here I will have, these are called junctions. This is the made of copper. Copper. Let me try to write the spellings. Copper. So we have taken two different metal wires. One is made of iron, the other one is made of copper. And their ends have been twisted with each other, both the ends. In the copper wire, I have connected a voltmeter also. So this is dipped in this beaker, and this is dipped in this beaker. In this beaker, normally we have crushed ice. See what we have here. Here we will have ice. So here you will be having melting ice. This is called cold junction. Okay. And here we put water which is boiling. So in this is called cold junction, and this one is called hot junction. So whenever there is a temperature difference between both the junctions, what happens automatically, naturally, by the mother nature, voltage is created, and that ammeter will show deflection. It shows that EMF is induced, voltage is created. The more the difference between the temperature of the hot junction and the cold junction, the larger will be the EMF produced. The more the difference between the hot junction and the cold junction in the thermocouple, the larger will be the deflection, which means a larger EMF or a larger voltage is created. So this is the structure of the thermocouple. Muskan, do you understand this diagram?
Yes, sir.
Okay. So you can draw this diagram, and you can also write hot junction, cold junction, iron, copper. This iron and copper I also have written. But where this I have shown this ice, you will write here cold junction. And where you have written this, where you have this hot junction. So kindly name them. Yes, I can see that diagram. That's good. So you see, we are looking at the marking scheme now. Question 11C, first part. He says this question is of 3 marks. 1 mark is for this point that you will mention 2 different metals connected together, iron and copper. 1 mark will be for saying that the voltmeter, ammeter or galvanometer in series. We have connected a voltmeter, so you get 1 mark for that. And a clear junction of 2 different metals used as the place to measure temperature. You have to show the hot junction and the cold junction. So Muskan, write your answer, whatever you will write. If you have written, you can read your answer.
In diagram, 2 different metals, copper and iron, are connected.
Metal wires, not just metal. Metal wires.
Voltmeter is also connected in this series. And then I have written that the more the difference in cold and hot junction, the more the EMF will be produced.
Okay. So we have 2 metal wires. One is made of iron, the other one is made of copper. In the copper wire, I have also connected a voltmeter. The ends of the iron and the copper wire, they have been twisted with each other. The one end, twisted end, is dipped in the ice, and the other end is put in the water which is boiling. The first one is called the cold junction. and the second one is called the hot junction. And whenever there is a temperature difference between the hot junction and the cold junction, the EMF is induced naturally, and the ammeter records it. It shows deflection. The larger the temperature difference between the hot water and the cold water, or you can say with the hot junction and the cold junction, the larger the temperature difference, larger will be the deflection in the voltmeter. If there will be a smaller temperature difference between the hot junction and the cold junction, the deflection on the voltmeter will be smaller. If there is no temperature difference between the hot junction and the cold junction, then the deflection will be zero. Do you understand? Muskan, do you understand?
Yes, sir.
Okay. So, let's go to the next part. This was a 3 mark question. He says, on your screen, we have this second part. Question number 11. May, June 2017 2-1 paper. Section B we are doing in this video. And this is the last part. State 2 advantages of a thermocouple thermometer over a liquid in glass thermometer. You see, the temperature range of the thermocouple is very large. Thermocouple can measure very low temperatures,
It has good
and thermocouple can also measure very high temperatures. So that's the one advantage. Its temperature range which it can measure is very high. And other advantage of the thermocouple, it is capable of noting down very quickly changing temperatures. Another advantage is that the thermocouple is very portable. Another advantage is that the thermocouple can take the temperature of a body at a distance. You can make those copper and iron wires longer, so it will be in the form of a probe, and from the hot body you can stand at a distance of like 3 meter or 4 meter. From a distance you can take a reading by using a probe. Probe means that the copper and the iron wire make it longer. It's portable. It's easy to read.
Yes, sir.
So we have to write 2 advantages. It's a 2 mark. Let me show you the marking scheme. So on the marking scheme, he says measure higher temperatures. We normally we don't use say that it's more sensitive. We don't say this in many other papers. He said that don't let the students write more sensitive. Here he has written, but don't write more sensitive. Measure faster changing temperatures. Reading can be taken more rapidly. Produce electronic output, and the output may be stored or processed. This can be used with the data logger, and that can be fed to a computer, and automatically you will note down temperature. Automatically graphs can be created. Okay, write any 2 changes instead of writing that is more sensitive. Don't write that.
Sir, I have written it has high speed of response.
Yes,
It has good accuracy.
you are using the word good accuracy. Do you even know what is accuracy is? How do you know that that's more accurate? It is temperature. This accuracy thing, cut this accuracy thing.
Okay,
Instead of
sir.
this, right? It can measure very high temperatures. It can measure very low temperature. It is
Wide
portable.
temperature ranges.
The laboratory thermometer cannot measure very high temperatures. It will melt.
So can we write it has wide temperature ranges?
Yes. It has wider temperature ranges, or it has larger, you can say it has larger temperature range.
Okay, sir.
So, by this question, this was the 11th C second part, and I hope that we have reached the end of the paper. Okay, so it's a blank page. Okay, so my dear students, today, so you see, today we have done May June 2017 2-1 paper. The subject we are studying is 5054. In this session, we have only done the section B of this paper. Section A we have done in another video. Today we have attempted in this session question number 9, question number 10, and question number 11 of May June 2017 2-1 paper. So everybody, thank you very much, and have a good day, and have a good day, and have a good break, because we are going on a break. We are going on a winter vacation. So have a good day, and God bless you all. Thank you very much.